Calculation of required speed to maintain a certain constant main engine power and fulfill charterers or owners' speed requirement in a charter party. The use of a constant engine power management is not new, but comes again back in the focus for fulfilling the CII requirements in the year 2023, where the CII was implemented and is in force. With a constant engine and power, ships will save by far more fuel oil and therefore less CO2 emission compared to a constant speed management. In a constant engine power, the speed will be regulated via the RPM, and if using a constant speed management, the speed will be regulated via the engine power, which results in a more of fuel oil consumption. Let us explain it in the hand of an example. So you are on a voyage from Port Spain to Hamburg. From here to Hamburg, you're on a general cargo ship, back cargo on board, no reefer. Your fuel oil consumption per day is 27 metric tons low sulfur oil, and low sulfur MGO per day is 8 metric tons. You have 100% engine power, which results in 15,000 kilowatt for a maximum speed of 17 knots. The voyage charter says average most eco speed. That's the average speed that's required. That is here for your ship 14 knots, engine on constant power. That is a requirement from your owner. This is a voyage charter, and therefore the ship owner is the one who requires what you have to do, and that is part of your voyage instructions. So, in your passage summary, what you have calculated, you know now that we have 4,294.7 nautical miles if we take the great circle distance and what we have done. Here we can see what are the apparent current angle information and also where the current is setting that you can get out if you have a weather routing program or you have a weather routing provider who will give it to you. Then we know already, okay, that is my distance. And if I now, for this distance here, it takes a speed of 14 knots, we are coming to 306.8 hours, which is equivalent to 12.7 days. So now, let us see how the current and wind will affect the ship during the voyage. So in the first 5 days, the current setting is 315 will assist, but not so much, average 0.94 knots, and the wind is from 135, setting the ship to port side, causing more resistance or less speed. In total, we have a current and wind influence of 0.4 knots here, which is less distance which I will run, and I have that because I have less speed. So that is, we can see how the current and the wind is setting. So in day number 6 to 9, the current in the average setting 135 degrees with average 0.2 knots, not assisting means less speed. Wind is assisting day 6 to 8, but later not assisting, causing a speed gain of 0.3 knots. If I take now both together, I have a speed gain of 0.1 knots. So that means I make a little bit more distance compared to 14 knots charter party speed. That we can see. So on the day 2, day 11, the current is not assisting. We have a speed loss of 0.3 knots. The wind and waves not assisting, causing again a loss of speed of 0.5 knots because we have resistance. And the total loss of speed is now for this 2 days 0.8 knots. That is what we can see this here. And for the last 1.7 days from Strait to Dover to Hamburg pilot, we have here a current is for 18 hours assisting with 0.6 knots, afterwards a gains with 0.7 knots for 22.8 hours, which results in a loss of speed of 0.1 knots. And the weather for the first 18 hours is assisting, here with 0.6 knots. Later, for the remaining, a gains with 0.4, which results in a gain of 0.6 knots. We put this together, then we have actually a gain of 0.1 knot if we consider current and wind for the last passage until I'm arriving here at the pilot station. So that is a total distance covered compared to the charter party. Speed of 14 knots is 72.72 nautical miles less, because I cannot maintain the 14 knots. And considering the weather and the wind, if I will not do anything, then I have 72.72 nautical miles less. So and that we can now calculate and as step by step. So the first day we said we have resistance 0.4 knots. So 0.4 times the 5 days, 120 hours, is 48 nautical miles less compared to the charter spar speed of 14 knots. Day 6 to 10, we said, okay, we gained 0.1 knot times 96 is 9.6 nautical miles gained compared to the charter speed of 14 knots, where we would have less than. Day 10 to 11, we had a loss, therefore for the 48 hours, 38.4 nautical miles less compared to the charter speed of 14 knots. And until Hamburg, that is the same. So we have gained here 4.08 nautical miles compared to the charter party's speed of 14 knots. Therefore, we have a total distance loss or gain of 72.72 nautical miles here lost against the charter party speed of 14 knots. So therefore, distance gained or lost divided by the time required at 14 knots is the speed factor to be added or subtracted from the charter speed to maintain the charter's requirement. So which means here the distance we lost, 72.72 nautical miles, we have to divide by 306.8 hours. We are coming to a factor of 0.2 knots. So the distance is lost, therefore to be added to the charter party speed. It means 14 knots plus 0.2 knots is 14.2 knot speed. This is now the speed what I have to require from departure on until Hamburg to maintain the 14 knots, considering the weather and the current condition on this voyage and for this voyage. So now I have the speed, and with the speed I can now find out what is the constant engine power required for this speed. Either we have tables for this, or you ask the chief engineer for this. He has graphical and also curves for this. So let us see how it looks like. So this is such a power speed curve. So now what we said, we have actually an we said 14.2, which is about here. 14.2 is here. So, and then we said what we are from this line, we go here. So that's it. So now we can see that my required engine power here is 9,000 kilowatt to maintain a speed of 14.2 knots. So this is how we calculate this. You can also use a program. You will find that in the program that is in data on the same. So which means we have here the time and the distance, charter parties, and here for all of these traveling days, we have now the resistance or not resistance, and then we can see, okay, what will be my distance covered, and that means less distance covered, and what is my speed to be added or to be subtracted. So, and then we are coming also here for 14.2 knots, and here we are coming to 9,000 kilowatt. So this is how we have to calculate it, and that is a way that we can maintain a constant engine power, and therefore we are saving fuel oils, and we are safe CO2 emission, and this has an influence and also on my CII. That means on my attained CII and therefore on my CII rating. So that's it. Thank you for watching.